Hi class, I'm going to discuss Appendix A4 today. It's in page 651, which discusses about inconsistent linear systems and systems with infinitely many solutions. Right? Before we get into this topic, let me remind you what we did last time. We discussed about linear systems with unique solutions. Means when we say linear system, it simply means uh, two equations with two unknowns, three equations with three unknowns that you guys familiar with, or so on, five equations with five unknowns. Likewise, right? So some of the systems you you already saw that we can solve and we get one solution. Some other equations we get no solutions. With some systems we get many solutions. When we say system, you should notice that we talking about two or three or four equations. That's what our system is. Linear system. Linear means we discuss first order equations. They all equations of straight lines, right? Okay, with that, now we already discussed about systems with unique solutions, means one solution. Today I'm going to discuss systems with no solution. This word inconsistent means system not inconsistent means this has no solution. This means no solution. And we also going to discuss systems with many solutions, or infinite number of solutions, right? Infinitely many solutions. So let's get an example. X plus 3y equal to 5, 2x plus 6y equal to 7. Now if you going to do this by hand, first you multiply first the equation by 2 and going to subtract 1 from the other one, right? If you do that, you will see that when you multiply first equation by 2, you get 2x plus 6y equal to 10, and 2x plus 6y equal to 7. Once this is the second equation, this is multiplied by 2. Here we did nothing, I just wrote the equation. Now once we get that, you immediately notice 2x 6y is the same thing on the left side. That means if you solve these two equations for y, they both have the same slope and different intercepts. Understood? If you solve these two equations for y, you will see they both have same slope but different y-intercepts, which means they are parallel, which in turn means they never intersect, therefore they have no solutions. They go parallel to each other, right? They are parallel so that they never intersect, right? Now if we try to put this in our matrix system, try to solve it in the way we learned, we can directly write the augmented matrix. The word augmented means something giving us more information, something added to the regular matrix. What's added? The right side is added, right? Coefficient matrix and the right side together is called the augmented matrix. There we can write the coefficient matrix. Coefficient of x is 1, 3, y is 3, 2, 6, right side is 5 and 7, right? When we doing that, please remember this first column. Notice first column gives us coefficients of x, and second column gives us coefficients of y, right? This third column is the right side, right? We're gonna use that later on. Just remember, first column gives us the coefficients of first variable, second column gives us the coefficients of the second variable, right? Now this is our augmented matrix for the system. We expect to get the same answer, means no solution, right? Now for that, we discussed we have to get the identity matrix on the left side, then right side gives us the solution, right? For that, first we make one of the diagonal elements 1, so this is already 1, therefore we can select this as our pivot, right? Taking this as pivot, next thing is to make the whole column including that we have pivot to 0, not the pivot but everything else on that column we have to make 0. For that we can do this operation row 2, this element. I told you just focus on this pivot and the element that we want to make 0. 2 minus 2 times 1 is 0, therefore we can write R2, which is 2, minus 2 times R1 equal to R2 prime, means the next row 2, right? Next row 2 element. Now once we do that, focusing on just this element and the pivot, this applies to the entire row and it gives us this result, right? So we did few examples with the last video. When we do this, you will see that we get this 6 minus 2 times 3 is 0, 7 minus 2 times 5 is negative 3, 2 times 5 is 10, with negative it is negative 10, 7 minus 10 is negative 3. Now look at this, left side it's all 0, right side we have a number. When we have that, we say system is inconsistent system is inconsistent therefore no solution. Right? Okay, that well agrees with what we learned with equation of line. So this system has no solution. Right? That is this. Now let's let me change a number. I'm going to change this to 10, right? Now before it was 7, it was like this. So you may take this as first example. This is example 1. I'm gonna change this. I'm gonna change this to 2 by changing this 7 to 10. Now once we do that, you will see when we multiply this, it is this. We didn't do anything to this. It stays the same. This this one, when we do 10, it will come here as the same thing, right? Then you see these two equations are the same, which means they both the same line, means both lines are overlapped. If this is one line, the second line overlaps this like this. So means at every point these two lines intersecting. We can think like that. At every point these two lines are intersecting. That means it has many intersection points in turn, which means it has infinitely many solutions, right? Let's see how it works with our matrix equation. Now let's change this augmented matrix according to that. If this is, when this is 10, this will change to 10. Then R2 dash, R2 minus 2 times R1, R2 is 10 now. 10 minus 2 times 5, 10 minus 10, which is 0. Now this change, when we have this entire row equal to 0, that means this system has many solutions. This has now with this, beside writing this has many solutions, we going to proceed a little bit and write this in a more gentle way. I mean, now I told you this gives us x coefficient and this gives us y coefficient. Same thing with this x coefficients and y coefficients, right? So in here we go little bit further and we write this answer more formally, like this way. Instead of saying system has many solutions, it is true, it has many solutions. Instead of saying that, we can say x plus 3y equal to 5. Now, what's missing in the second row is we expect to get 1 here, which is the coefficient of y, right? Since coefficient of y is missing, we can give it we can assign a arbitrary constant. We can say y equal to, this is the new thing that you're going to learn here. We say y equal to k, an arbitrary constant, where k is an arbitrary constant, right? Then we can write this in terms of y. If you solve this equation for x, what we get, x equals to negative 3y plus 5, right? Substituting this y here, we can say x equal to negative 3k plus 5 and y equal to k, right? This is a more formal way to say the same thing. Here I told you k is an arbitrary constant, means k could be any number. As k changes, x and y can get infinitely many solutions, right? So that's the whole story in short, right? How we recognize it quickly. If we have only left side of the matrix 0 but we have a number here, then we say system is inconsistent. But if the whole row is 0, it has many solutions. There you go ahead and do this thing. If the whole row is 0, here you do not write simply it has many solutions. Instead you take this one. This is the row belongs to y, means once we get, again I'm telling you the important part, here we could make 1 for the x variable, but the next one we wanted to make 1 which is the coefficient of y. When we try to do that, we get 0. Therefore y the y element will be missing, because 0 times y is 0. Therefore what we do is we assign an arbitrary constant for y, right? We assign an arbitrary constant for y, then we express x in terms of k, the arbitrary constant, right? Okay, let's see an example from the book. I will erase this board. example 3. This example is from the book. It is in page 652. Okay. So we know now what we got to do. First write the augmented matrix. One, two, three, 9. Right. Now, what's our intention? We want to make identity matrix here, right? We do row operations to get identity matrix on the left side. For that, first we want to make one of these diagonal elements. These are the diagonal elements. We want to make one of the diagonal elements 1. Okay, in this case we already have 1 here, therefore we select this as the pivot. Right, that's the pivot. Then if it was not 1, we know we have to divide that by the same number. For instance, if I remind you, if this was 3, then we say row 3 divided by 3, then we have to divide entire row by 3 and we get the next matrix. Now we have 1 in one of the diagonal elements, so we are done with that step. We can do the next step, which means we have to make the entire row containing pivot element to 0, right? Not pivot, but everything else we want to make 0. This 0 and this 0. For that we can do R2 prime equal to R2 minus 2R1. Now you might be familiar with this, and to make this 0, this means third element next matrix prime equal to this one. We take this one, which is R3 minus this minus 4 times 1. 4 minus 4 times 1 is 0. 4 times 1. Right. Then that gives us these two elements 0, and accordingly this entire row will change. Right, we get this matrix. Now what's the next step? This was the pivot. Now we want to make another element 1. Okay, again automatically this one becomes 1 when we do the row operations. Therefore we can take this as the pivot now, and we can make these two elements 0. Right. For that, we can say R1 equals to R1 minus 2 R2, and R3 prime equal to same number. Therefore we can say R3 minus R1. R3 minus R2. So that gives us seven. We get this matrix. Let me see. Yes. Okay. Now again we got a inconsistent system. How do we know? Only left side is 0, not right side. This is 0, this is not 0. See, therefore we can say system is not consistent or inconsistent. Right? System is inconsistent. That's our final answer. Let's do another example. This one is pretty similar to the one we did. Let's do a different type of example. Okay, in the next example given in the book, it's all zeros. Then we know how to do the answer. Looking for something different. Okay, by the way, when we solving the matrix, once we arrange 1 on the diagonal here, this becomes 0, but other two becomes 1. When we try to make this 1, it becomes 0. This matrix where all elements on the diagonal is 1, and we have to arrange the matrix the left with the first row. 1 should be on the leftmost. The next column, the 1 should be after this position. If we could get 1, means it should not be appear here or here, it should be there, right? So if we could arrange all of them to 1, and these ones in the order, in the first column 1, with the second row, second column is 1, third row, third column is 1, we call that row echelon matrix. You do not need those names, but I'm writing it. It's called row echelon matrix. Then if we could make this to 0, means only diagonal is 1 and everything else is 0, it is called reduced row echelon matrix. Here we cannot get reduced row echelon matrix because this is 0. Since this 0, we cannot make these two elements 0 using this, right? Try to make it 0. This minus whatever the number times 0 is 0, therefore you cannot change this to 0, right? So that's all about it. Okay, let's do this example. Okay, this is example 2 in the book in 664. I change it to our number 4 here. The only difference is they changed this to this change to 21, right? So we have to change this accordingly. Okay, this is 21, therefore this is 21. Minus 4R1, this wouldn't change. Then this would be changed to negative 15. Okay, then this one these two row operations also not changing, but since we have the same number here, negative 15 and negative 15, when we do this operation, R3 minus R2, negative 15 minus negative 15 is 0, therefore this will change to 0 now, right? Therefore, instead of saying the system is inconsistent, we have thing to do. Now the system has many solutions. Now system now which coefficient is 0? I said first column is x belongs to x, second column is y, third column is z, right? Now we can, what we're going to do is we can write these equations back. I'm gonna write it here, right? One other thing changed. No, this is the same. It should be the same. 39, negative 15. Yes, this is good. Okay, now let's write 3 equations for the system now. We get x here, y times 0 is 0, plus we get this 7c equal to 39. We get y minus 2z equal to negative 15. Now the one corresponds to z is missing. Instead we have 0. So for that we say z equal to k, right? This is z equal to k. So if you solve this first equation for x and second equation for y in terms of z, we get, this implies x equal to 7z negative 7z plus 39. This gives us y equal to 2z minus 15. I write this one as it is, z equal to k, where k is an arbitrary constant. Right. Now I converted this augmented matrix into equations. We get this and we assign k for z. Right. Now I'm gonna erase this. We can write these equations substituting k wherever you see z, right? So x equal to negative 7k plus 39, y equal to 2k minus 15, z equal to k, right? Okay, that's all. So this is our final answer. The rest of the examples are pretty similar, but let's do another example or two. I'm gonna erase this. Let's do this. I picked this one because it has 4 equations with 4 unknowns. Now this is the question we want to solve. Question is to solve. First we do the augmented matrix 1 1 1 5 2. Negative 9 30 3 2 6 8 2 5 negative 7 31 negative 38. Right, once you see the question of maybe 4 equations with 4 unknowns, maybe 5 or 6, don't just like, oh my god, no, first do whatever you can do, then think. Right, now we can write the augmented matrix, so I just wrote the augmented matrix. After that we look at the diagonal. This is the diagonal. We have negative 1 here. Okay, now I let you do row operation. Here you see one of the diagonal elements 1, you may pick this one and then make this the rest of this column 0, taking this as the pivot, then next one, do that row operations. Finally I picked this question because not just because it has 4 equations, but also it has 2 0 rows. I write the final matrices, augmented matrices, we get 1 0 4 negative 2 0 1 negative 3 7, all these 0, and this side 16 negative 48. Once this diagonal becomes 0, you cannot make this column 0. Once this diagonal element becomes 0, you cannot make any of these column elements to 0. Right? After that we just stop for a while and think, okay, we have left side 0 and right side 0. If only left side 0, and if with any of these two, if you see only left side is 0 but right side, if you see a number, you simply say the system is inconsistent. That's it. Right? No solution. Right? System is inconsistent, therefore no solution. But if you have left and left side and right side both 0, we have to proceed with that constant, right? So there, when you're writing equation, it is pretty useful. You write x, y, z, w, whatever the letters given in the question. X, y, z, w, these are the given variables. We wrote it there. Then we can convert this augmented matrix to equations. We can say x plus 0y, you don't have to write that, plus 4z minus 2w equal to 16. This is y minus 3c plus 7w equal to negative 14. Now the next one corresponds to z is 0 and whole row is 0, therefore we have to assign a constant for z. So I get the same letter as Book did. They took z as k. We can assign z equal to k and w2, this position is 0. If we had 1, we can say get z. If we had 1 here, we can get w, but there is no 1. Instead we have 0 here, therefore we have to assign an arbitrary constant for both these, z and w. That's the reason why I picked this question. Okay, this is L, right? Okay, now I'm gonna erase this part here. So solve these two equations for x and y. So we get that in terms of z and w, x equal to negative 4z minus 2w plus 16, y equal to 3z minus 7w minus 14, z equals k and w equals to L. Now these z and w we can replace with k and L. X equal to negative 4k minus 2w plus 16, y equal to 3k minus 7w minus 14, z equals k, wait, we have to k and L, 4k minus 2l, this is k, this is L, this is k, this is k, and w is L. So this is our final answer, right? comparing with the book. Minus 2w. When you move this to the other side, this should be plus 2w. Therefore, when we convert, this is plus 2l. Right? 16 minus 4k plus 2l negative 14 3k minus 7l. Yes, that's good. So that's our final answer. Right? Okay. Let's do this one. Changing this to 6. We get x minus y plus x minus y plus z plus w equal to 6. Minus 3y plus 3z plus w equal to 7. X plus y minus c minus 3w equal to 4. Now, if you get this question before you take this class, you say, okay, this is we have 4 unknowns, but we have only 3 equations, therefore we cannot solve it. No solution, right? But here we can do something more than that. First thing, write the augmented matrix. Stay calm and write the augmented matrix. Two negative 3, 3, 1, 2 negative 3. 1, 1, negative 1, negative 3, 4. Okay, we get this matrix. Now, this is the diagonal. Right? Now, this is the thing. To have a diagonal, we have to have a square matrix. You may assume, in that case, you may assume we have fourth equation like this: 0x plus 0y plus 0z plus 0w equal to 0. Assuming that, we can write third row here, 0, 0 here, 0, 0, right? You don't have to write that, but at least keep that in mind. Okay, we can have zeros there, right? Which means 1 2 3 4, 1 2 3 4. Third element, this is 0, this is 0, and this should be 0. That's the diagonal element, this guy, right? Okay, again, you don't have to write this, you may keep that in mind. The thing is, we can have diagonal. If we had only 3 rows and 4 columns, we cannot have diagonal. Then we can write these zeros and have diagonal, right? If you just assume this 0 but not write it, then you have to take these 3 as diagonal elements, right? Now after that, you do row operations. The intention is to make these ones and everything else 0. Make the diagonal 1 and everything else 0. When we doing that, you come to a place like this. You get a matrix like this. One, 0, 0, 2. I'm copying this from the book. Negative 1, 1, 1, 2. These are zeros. Okay. If you just assume last row 0, you get another zeros row here. You get this. Then what can we do? This is the diagonal. Now after this step, you see you cannot make this 1 be you get 0, therefore you cannot make this 0. Then you have to stop there. Then think about those variables. This is x, I write it in a different color, x, y, z, w, right? Now what's missing? We have x, we have y, no z, no w, right? Right. Therefore, we can either write zeros here. You don't have to. We can straight write answers here. X plus 2w equal to 11. Now again, once you get diagonals 1, but other things, some of the other elements not 0, you say this row echelon matrix. I just remind you the name. We can write solutions now. X plus 2w equal to 11. This gives us x equal to 2w negative 2w plus 11. This is y minus v plus w equal to, okay, let me write it here. I don't have space here. Plus 2w equal to 11 y minus z plus w equal to 5. This one gives us w equal to 2. What's missing? The next row, right? So even with w, we see we have 1 there. Means we can okay, let me explain you that before we proceed. Now we have this 1 here, right? Then if you assume a 0 row, we have zeros here and here. This is your diagonal. Then what you may assume to do is, okay, you can write this as, you can, this is w, what's missing is z, right? What's really missing is z. We have x 1, under x we have diagonal 1, under y we have diagonal 1, under z we have nothing. But with w, we have 1 there. If you swap these 2 rows, right, I show you that we can write this as 1 0 0 2 11 0 1 negative 1 1 5 0 0 0 0 and we have 0 0 0 1 2 here, right? So this is this 4th row. I swap with 3rd and 4th rows. I swap 3rd and 4th rows. So looking at this, you see, now you see clearly what's missing is z, right? Therefore we have to assign a constant for z, not for w. In w we have only 1, everything else 0, so we get straight answer w equals to 2, right? So 3xy, before I write, you don't have to do that. Since we missing z, we assign a constant k here, and w is 2, right? Then we can write x and y in terms of z and w. This gives us x equal to negative 2w plus 11. This gives us y equal to z minus y equal to z positive z minus w plus 5. This stays the same. And w equal to 2. Right? Now we can write x and y in terms of substituting z equals k and w equals 2. Right? I'm gonna write it here. X equal to negative 2 times 2 plus 11. Y equals to z is 2. Y equal to z is k. Z is k minus w is 2 plus 5. Z is k and w is 2. So this gives us x equals to negative 2 times 2 is positive, I mean negative 4 plus 11 is x equal to 7. Y equal to k plus 3. Z equal to k and w equal to 2. So this is our final answer. Right? So what's special there? When we get this answer, I'm sorry, I think I erased that line. There we see W line, the fourth line, we get 1 here. Then what we did, we swapped two rows, right? Okay, let's see if anything different. Now this is a question with 3 equations with 4 unknowns, right? 4 unknowns means number of unknowns are more than the number of equations. Now let's get an example other way around. Means when we have more equations than unknowns, right? I'm gonna erase this. you see something strange? We have only two unknowns, but we have three equations, right? Let's see what we can do. Whatever it is, you know, we first write the augmented matrix. 1, -2, 6. Okay. Now, here you should not think, okay, we have three equations, but only two unknowns. It is something strange. No, simply do what we being doing. Uh, what we being doing? We wrote the augmented matrix, and we try to make these diagonal elements 1, and let's see what happened to this this third row. So we want to, with this so-called diagonal, you cannot include this 5. If we had third column, we have the diagonal here. We cannot say this is a diagonal because this is not a square matrix, but we try to make this 1 and everything else 0. This 0, this 0. This is already 1. Right? So we can easily pick this one as our pivot. Then we have to make this column 0. Then we pick this as pivot and make this column 0. Now when you do row operations, now you know how to do that. You end up getting this answer. I write the answer. When we make this and this to 0, you will get 1, 0, -12, 0, 1, -9. Last row all zeros. Right? So corresponding variables x, y. Right? Now looking at this, we can say x equal to -12, right? X equal to -12, y from this row, y equal to -9. This is the answer, but what about this third row? Before we assign a variable a constant, like if we had z, we said it is k, but in this case there is no third variable, therefore nothing is there. This is the final answer. Right? But I would like to tell you this. If you had anything beside 21 here, right? Say I simply take off 1 here to make the example 8. When we do row operations, this is not 21, this is 2 now, and here you get a different number. I just write number here. Right? When we have number, if you get this, you cannot write this as the solution, right? I hope you get the previous question. So I'm gonna erase this. This is not the answer. Now we have left side of a row is equal to 0 and right side is a number. I write this symbol to indicate it is a number. Then the system is inconsistent. We cannot say, okay, x is negative 12, y is negative 9. We have to take care of this line. Means when we take care of this one, we see left side zeros and right side number. We see the system here is inconsistent. Not consistent or inconsistent, it's the same thing. Either way, it has no solution. Therefore, system has no solution. Alright, system has no solutions. Okay, let's see what else. Now, okay, that's all about Appendix 4. But I would like to tell you something. When we reducing this matrix to reduce row echelon matrix, give you an example. I'm gonna erase this.